Okay, everybody can see that, okay? Here's what we're doing. This wants us, so this is like titled investigation, so it's a little bit more for you guys just to kind of put your head down and like work your way through. So you had that opportunity like at the end of the day, kind of last period yesterday, so we'll just go over that first little bit, and then I'll give you the same opportunity for the second and third pages, okay? And I'll bounce around, okay? Percentages are basically like compressed versions of ratios, if you will. Does that make sense? All this work, it's like a fraction, but it's not a fraction, okay? So what we can see here is if I were to color in 50% of this region, what is, like, most of you are okay with that. Like, what does 50% look like? Half. So I'm just going to color in half. Some of the issue arises once we get into like, oh, I don't know, 3/64ths or something. Like, how do you color that in? What does that look like as a percent or something? You know what I mean? A little bit tougher. But for this one, you're going to color in. I'm going to increase this size so we're not here all day. You're going to color in half the section, half the region. Okay. Now, it's saying 50% of 100 is what? How many boxes did I color in there? Assume, yeah, we have to first know how many boxes there are in total. How many is that? 100, and we found that we could have found that out by doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 by 10. Then I know there's 100 boxes. Yes, Harry?
My alarm went off to tell you.
Oh, thanks, buddy. What if you weren't here by 9? What would we do? We'd be getting a phone call from Ruth. Hey? Drayden, not here. Austin Henry, not here. Anybody else? If you're not here, say so.
Katrina's not here.
You see what I did there? If you're not here, say so.
I'm not here.
Katrina, that's right. Sorry. Okay. That's it. Haha. All right. So, 100 squares. So, if I color in half of them, how many did I color in there? Kiriana? 50. Right? 50% of 100 is 50. Okay? That's how many boxes I colored in there. 1, 2, 3, 4, 5 times 10 is 50. Colored in 50 boxes. Right?
Or even 1 and 2.
Yeah, you can always reduce them. That's what we've done some of that already, right? Okay. Let's kick it up one notch. So it's not nice numbers now, right? But in bouncing around yesterday, I used the explanation of like $1 and how many quarters are in $1. Like, forget about fractions here for a sec. Not talking about quarters of fractions, like money quarters. How many quarters make $1? Carry on. 4. There's a reason why they're called quarters, right? So there's 4 of them in $1. Same idea here. So if it says, what would be 75%? 75 cents of $1. How could I make 75 cents?
3 quarters.
3 quarters.
Or 3/4.
Or 3/4. Or 3/2/4. Not 3/2/4, but I mean like this. That's like a math joke. I'm trying to spice it up here. Not 3/2/4. Okay, 3/2/4. So let's shade in. We got to shade in 75%. So 3/4, right? 1, 2, 3. How many boxes did you color in?
How many boxes?
Thank you, everybody. 3. Okay. That's a little bit harder. Let's go one step further. How many boxes do I see here total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I need to figure out how many of these boxes to color in. What is 30% of 3 boxes? That's good, Cole. Good, buddy. Okay. So I'm going to color in 3 boxes. 1, 2, 3. So 30% of 10 is 3. Okay. So it's kind of interesting that we get 2 of the same number of boxes, but they're under different percentages and different total number. That's kind of interesting, right? Does that make sense? Any questions?
Just because the whole little figure is small.
The whole, yeah.
Like what it's being divided into.
Yes, what do we call that? I know you guys have talked about that with Mr. Irvine. What we divide by. There's a specific name for that in a fraction. So we have in a fraction, this is a fraction, right? In the top, we have what we call a numerator.
Oh.
And in the bottom, we have denominator. Right? So this is what we call the whole piece, or what we're dividing by, right? The denominator, exactly what you just said. Okay. Okay. Can we write, we'll do a little bit, and then I'll let you guys, I'll get to like, I don't know, we'll do this question, up to this question, then I'll let you guys try that. At least then you have like I don't know, we'll do 5, okay? That way you guys have like an example to go off of. Okay? So if 50% of 10 is 5, then 50% of 20 is 10. That's a bit of a jargon. All it wants you to do is say, okay, it wants you to write equivalent ratios that we've done already. So what it's saying is 5 to 10 is equal to 10 to 20. Right? Those two things are equivalent. So if I wrote, remember yesterday we talked about what equivalency meant. How do I get from here to here? We multiply by 2. Do I have to multiply by 2 up here to get from there to there? Okay, so because I have to multiply by 2 in the top and the bottom, then they're equivalent. That makes sense? Okay, that's why they're equivalent. Here's another thing. Can somebody divide, or I'll do this part in purple. Can somebody like tell me what 5 divided by 10 is? As a decimal? What is 5 divided by 10? 0.5, right? What's 10 divided by 20? Same thing. So because these two things are the same, they're also equivalent. That's how you know. Okay. What is the scale? We already kind of did this. What's the scale factor between the two ratios? These two up here. These two ratios. It wants to know the scale factor between them. What is it? It is 2. Scale factor is that. So the scale factor is actually 2. Okay? So I would say, well, there's multiple ways to do these questions. We'll do this one, and then I'll let you guys just chip away at it at your own pace, okay? Here's what I want to do. How could I represent 12%? If you look back at the other page there, or the first page, how did we represent 50% relative to 100? How did we do that? How many boxes did we color in? Half of them, which would be what number? 50. Okay, good. So if I just don't change anything at all, I just reset the picture, and I want 12% this time instead of 100. How many boxes am I going to color? 12. So if I write my fraction like this, 12 out of 100, right? That's 12%. But that's equal to, you want to find 12% of 40. Right? So remember, the top is kind of like your percentage. Just keep it in the back of your head. That's like the number that's going in top, or the number out of 100. And you want to find what out of 40. You guys know how to do this. Right? You want to find the question mark. Okay, so here's the direction of travel. You're going from 12 to the question mark. So you better go from here to here, down in the bottom. Do the numbers get bigger or smaller in the bottom? Smaller. So I know I have to divide in the top and the bottom. Okay. Now what is 100 divided by 40?
2.5.
Okay. So I know I have to divide them both by 2.5. Okay. So your question is, the question mark is equal to 12 divided by 2.5. What is that number? 4.8, eh? So what's the fraction then? What's your final fraction? What number? I didn't really ask that question very well. Does that look right? This is 12%. Does that make sense? That's using all our ratio work that we've done so far and just incorporating percentages. Okay. Percentages are a ratio. 12 boxes out of 100. You can write it like that. And then you could find I could find 12% of 60 using the exact same thing. I just put a 60 where the 40 is. And I use all my proportion work. Does that make sense? Okay. So you guys try that. You've got a couple questions there. You got 2 questions. You can try that, okay? And then I can maybe show you how to use the second page too.